Hello, I welcome you all to this another interesting screencast, and the problem reads: determine the greatest load P that can be applied to the truss so that none of the members are subjected to a force exceeding either 2 kilonewtons in tension or 1.5 kilonewtons in compression. This problem is coming from the Engineering Mechanics Statics textbook, 13th edition by R.C. Hibbeler. So let's look at this particular truss. When we look at this truss, we realize that this is symmetrical about this axis, right? So the loading is symmetrical because even the reaction forces, you just expect the vertical reactions, the horizontal will be equal to 0. And the geometry also is symmetrical about that axis, and it makes the problem much easier. Okay, right. So first things first, because of symmetry, we know that the internal force in AC is going to be equal to the internal force in BC. Okay, because of symmetry, symmetry, because of symmetry, we expect AC, the load is symmetrical as well as the geometry. So we expect AC to be equal to BC. All right. But then what we're being asked this time around is to find the greatest load P that can be applied to the truss. But there are conditions, not two conditions, there are conditions. So when we calculate this greatest load P, we must note the P must ensure that it does not exceed a tension of 2 kilonewtons, or that greatest load P must ensure that it does not exceed 1.5 kilonewton in compression. So there is an or, all right? And these two conditions, we need to check them, all right? So we don't want tension to be 2 kilonewtons, okay, to exceed 2 kilonewtons. We do not want the compression to exceed 1.5 kilonewtons, all right? These two conditions. So we need to check them one by one. And after we've done so, then we are going to come up or determine the greatest load P. This P must ensure that we do not exceed the tension greater than 2 kilonewtons, or we do not exceed the compression of 1.5 kilonewtons. These two conditions, right? Again, there are a lot of ways to solve this particular problem. For us, we are going to start with working out the support reactions, and afterwards we'll find the internal member forces, all right? And once we've done so, then we are going to start checking case by case. Case number one, tension equal to 2 kilonewtons, and then we'll check the value of P, and then we'll check the compression, whether it exceeds 1.5. All right, and then the other case, we are going to say compression 1.5. Then we check whether tension is exceeded D, okay, which is a 2 kilonewton, whether tension is exceeded. All right, so let's start working. We have AY here, and then we have AX. Then here we have BY. And like we said, there is symmetry, so this problem is much easier. Okay, so we know that at that point, like so, I'm just trying to, these are the, from there to B, like so. Okay, those dimensions there, this is going to be 1.5 meters, and this is 1.5 meters. All right, and uh, the internal angle for a triangle is 180. So if this is 60, the internal summation of all internal angles is 180. So if this is 60, this is 60. So 180 minus 120, we realize that this is also 60. Okay. And if this is 60, then we can share it in between for the sake of calculating the components of these particular forces later on at some point. So this will become a 30, this will become a 30. All right. So now let's start working. So we'll say summation of moments about point A equal to 0 and clockwise in our reference. So we have a minus P by 1.5 by plus by by 3 equal to 0. And therefore our by is just going to be equal to, our by is equal to, so we have just 1.5 p divided by 3. This gives us a 0.5 p. Okay. And then we have summation of forces in the y equal to 0. Alright, what do we have? We have ay plus by minus p equal to 0. We've already found what p is, what by is. So let's replace it where we're supposed to. And once we've done so, we'll find that our ay is also equal to 0.5 p because of symmetry. Okay, so this is equal to 0.5 p. This is equal to 0.5 p. Okay, let me just create this boundary. And then finally we have summation of forces in the x equal to 0. We know that our ax is just going to be equal to 0. So this is equal to 0. Right. So having found the support reactions, let's now find the member forces. Okay, and state whether they're in compression or not, and then apply these two cases. So let's go to joint. Let's go to joint. We just need one joint, okay? Because once we found AC, then we'll know what BC is. So let's pick joint A. Just one joint is enough. Okay, joint A. So there we go. So let's say here we have compression. This is our AC. Okay, and then here let's say we have tension. Okay, and this is our AB. And this angle there, it is 60. And then we have an external reaction force 0.5 p. Right, so let's find this. So let's first find the components of AC. AC will have this component. It will have this component. This is AC. This is AC sine 60. Alright. And this is AC cos 60. Okay. And then let's start with summation of forces in the y. Summation of forces in the y equal to 0. Going up in our reference. So we have 0.5 p minus AC sine 60 equal to 0. Therefore, our AC is just going to be equal to, so 0.5 divided by sine 60. So this gives us a 0 point. What has happened? Okay. What has happened? Alright. Sorry about that. My pen had just started it had just stopped writing. 0.57 7774. Okay, So 0.5774. Okay, P. Okay, then let's find B. And therefore we said AC is equal to BC. Therefore, AC is equal to BC, which is equal to 0.5774 P. And this is in, we had assumed it to be in compression, and we found no change of sign, therefore this is in compression. Then we have summation of forces in the X equal to 0, in this direction being our reference. What do we have? We have AB minus AC cos 60 equal to 0. We found our AC already, so we can just replace it here. And once we do so, then we'll find that our AB is going to be equal to 0.5574 by cos 60. So this gives us 0.5774 cos 60. So we'll have a 0.2887 P. Okay, and this is in tension. Alright, so now let's start checking the cases. Now we found the support reactions, we found the member forces and their directions. So now let's start. Right, so let's now check case by case. So we have case 1. Case 1, maximum tension is equal to 2 kilonewtons. Which members are in tension? The members that are in tension is AB. Okay, so therefore AB is equal to 0.2887 P will be equal to 2 kilonewtons, and P therefore in this case will be equal to, let's find what P is, 2 divided by 0.2887. Then our P is equal to 6.9276 kilonewtons. Okay, so 2 divided by 0.2887, 6.9276. So we are saying this is the greatest load, but we are not yet done. We need to check the compression. So check the compression. So we need to check, okay, check the compression in the other members. Okay, so check compression in members AC or AC, okay, because we know AC is equal to BC. So AC is equal to 0.5774 P. So we are going to replace the P that we just found. Okay, we'll replace the P that we just found here. Let's do the replacing. We'll replace here, and once we replace that P, we'll find that AC is equal to, mind you, this is in compression, AC is in compression and is equal to BC. So 0.5774 times 6.9276 gives us a 3.999, a 4 kilonewtons. What is our threshold for compression is 1.5. Therefore, this is greater than 1.5. Therefore, not okay. We can't pick that value of P. We have to go to case number 2. So go to case 2. Say compression, we'll call it just C. C max as our compression equal to 1.5 kilonewtons. Which members are in compression? AC is equal to BC, so we can pick any of those members. Okay, let me just create a boundary here. So let's pick any of those members. So we'll say AC therefore is equal to 0.5774 P equal to 1.5 kilonewtons. And from this we'll find that our P will be equal to 1.5 divided by 0.5774. So we get a P of 2.5979, okay, kilonewtons. 1.5 divided by 0.5774, 2.5979, okay. So but we are not yet done. We need to check the tension. We need to check the tension in the other member. So let's check the tension because those conditions have to be met. So check tension in member AB. Okay, so we said AB is equal to 0.2887 P. So we'll replace this P here. We'll get this P. Come and replace it here. And when we do so, we'll find that our AB is going to be equal to 0.2887 times our P. We found 2.5979. And we are finding that our tension in member AB is equal to 0.75 kilonewtons. And what is our threshold tension is 2. So this one is less than 2 kilonewtons. Hence, okay. Alright. So this one is okay. Hence, okay. I don't know why it's okay, like so. Hence, this one is okay. Alright. So what we need to do now is to write down the final solution. So we've seen that the one that meets either of these conditions, we are saying we need to find P, the greatest load P, that must ensure that the tension does not exceed 2 kilonewtons and or the compression does not exceed 1.5. So the value that we are going to pick will say, let's say P largest, right, is going to be equal to minimum value from the two values of P. So we have one which is equal to 2.5979, comma, the other P was 6.9276. Okay, from these two values, our P largest is the minimum one. Okay, is the minimum value because it meets either those conditions. It's going to be equal to, we round off 2.59, it becomes a 2.60 kilonewtons. So this is our final solution. Okay, P largest is equal to 2.6 kilonewtons. When we apply a 2.6 kilonewtons there, our tension will not be exceeded. We'll have a tension in member AB of 0.75, okay, which is less than 2 kilonewton, okay, 0.75. Great. But of course, in members AC and CB, we are going to have the maximum compression, which is 1.5. Right. I hope the video was helpful, and if it was, give me a thumbs up, like my video, and continue subscribing. Bye bye, and see you in my next screencast.